and welcome back to Algebra 1. Our goal for today is to look at how we use our greatest common factor of our terms of a linear binomial to do the process of what's called factoring. Now, we've talked about factors a couple of times this year. Factors when we have a power, like a to the third. Your factors are a times a times a. It is your items you can multiply to get back to the original value. We also looked at what's called prime factorization, which is breaking down a value into its prime numbers that could be multiplied to get back to the original. So whenever I see this word factor, this word right here, a factor, that's telling us I'm trying to break apart the problem back into things that could be multiplied to give us the original value. So that's our goal for today. Can I take what's called a linear binomial and get it back to items that I can multiply it together to get back to the original? So for example, if I have that linear binomial, 20m plus 100, there's a whole bunch of different ways we could go about factoring it or breaking it apart into things that could be multiplied to get us back to that original value. So for example, one example would be I could factor out a 2. Right? And I can say that 2 is being multiplied with whatever else would be left over. So what would be left over here would be 10m and 50. And I think we're at the point that we understand if we were to distribute the 2 back to the 10m, we'd get back to this 20m. And if we distribute this 2 to the 50, we'd be back up here to the 100. And we've now done this process of factoring it, right? We have things that multiply that get us back to the original thing, right? There's other ways, right? We could have done it differently. Maybe I pull a 10 out. I factor out a 10, right? That would be a way to factor here. So if I pulled a 10 out, we'd end up with 2m plus 10. And again, I think we understand that if I were to distribute that 10 to 2m, we'd get back to the 20m. And if I were to distribute the 10 to the 10, we'd be back up to 100. Right? There's other ways. Oh my gosh, I could have pulled out a 5, right? That would have worked. If I did that, I would have 4m plus 20. And that would be a way to get back, right? We factored the problem by breaking it up into things that can multiply and get us back to the original. All right, we could also do something like this. 1/2. I factored that out, which means we'd have 40m plus 200. Right, that's a way we could factor it apart. So when we're done today, how do I know that I have the correct factored version? All right, so for today, we're not just factoring, right? Because we can see there's endless combinations here of factoring the problem. We are factoring completely. And when I say factoring completely, that means I'm pulling out the greatest factor I can possibly pull out. So is this outside number the greatest value I could possibly pull out? And the way that I get that greatest number is by finding the GCF, like we did yesterday, of our individual terms. That's the number we always want to factor out so that our problem is factored completely. So when we look at a whole bunch of different possibilities here, right, there's endless possibilities. The best way to have factored it is by pulling out the greatest common factor of 20m and 100, which would be this value 20. So that's our goal for today. Can I factor a linear binomial completely by pulling out the greatest common factor value? All right, so our steps for today. All right, factoring is the process of breaking up an expression into terms that can be multiplied to get the original expression. All right, so we looked at this picture the other day. This is what's called the expanded version. What does it look like after we distribute? Or what does it look like after we multiply? That's your expanded version. This down here is your factored version. Factored, right? The 4 times 5k plus 7 is what's called your factored version. And the reason it's called your factored version is it's in the format of what should I multiply together to get back to the expanded version. All right, so for today, I'm giving you this version, the expanded version, and our job is to get to the factored completely version. So our steps, we're going to factor an expression by finding the greatest common factor of the terms in the expression. Remember, for these, since we're factoring our terms, we want to start with 1 in our number and -1 in our number. If we don't do that, we might miss something that's part of our GCM. So start there first. In your trees, 1 times whatever or negative 1 times whatever. All right, from there, once we figure out our greatest common factor, that's going to get pulled out. To figure out what goes in the leftover part, the parenthesis part of the factored version, is we take each individual starting term and divide by what we just pulled out. GCF goes on the outside, either in the front or the back, and the leftover stuff is your parenthesis part of your factored version. All right, so let's look at some examples. All right, we want to factor the expression 4x plus 12. All right, so I'm going to do, your paper's broken up here with 2 sides. This side over here is your steps of work, your required work. For these problems, there's 1 required step. That's it, fairly simple. This side is your scratch paper work that helps you. So for today, I'm going to ask that you show both, right? For your activity day, you're going to show both. All right, so make sure the easiest way to do that would be sort of put a tall, skinny hot dog bun style fold in your paper and show both sides. All right, so over here, since we're working in our notepad right now, we don't need to do that. All right, these are both positive numbers. So we're going to start with 1 and 4 and 1 and 12. And then we're going to keep going from there. So 2 and 2 and an x. We finish our 4x. And then 3 and 4 and 2 and 2. All right, let's start building our chart. Our lowest number is a 1, and they both have it. Gone, gone. All right, our next lowest number is a 2. There are 2 for the 4, and there are 2 for the 12. Boom. All right, there's 1 3 on the bottom, so this top one stays blank again. Please don't put things up. Don't put that x above it. It doesn't work. And then put your x in a new column, and the bottom one stays blank. All right, so GCF says this. Any column that's full, I have to multiply to get the greatest common factor. So 1, 2, and 2, right? So 1 times 2 times 2 will give us our greatest common factor. So 1 times 2 times 2 gives us a GCF of 4. All right, so let's go to our step side. 4 is what's going to go up, right? That's one of our factors. And then we need the other factor, right? This is our times right here, right? So this is a factor, and this whole thing is going to be our other factor. All right, the way that we get that, there's 2 ways we could get it. I go to my chart, and whatever's left over will be our values on the inside. So this top will represent the first thing left over. So gone, gone, gone. The only thing there is this x. That's what's left over. And then on the bottom represents what's left over from this 12. All right, so gone, gone, gone. All that's left is a positive 3 plus 3. All right, that's one way to get it. Or the other way is I take these original guys, 4x and 12, and I divide them by what I pulled out. Right, divide by 4. Right, both work. And that will give you your leftover part. So our factored completely version here, 4 times x plus 3. All right, over the next couple of lessons, we should get to the point where we might not have to always do the chart. But again, for today, we're going to show all of our work, including our scratch. All right, number 2. We want to factor completely negative 72w minus 16. All right, these are both negatives. So we're going to start with negative 1 and 72 and negative 1 and 16. And then we're going to only break down the positive version. If I don't do that, I might miss something that is part of my greatest common factor, so be careful. All right, let's start to break down. 72, we can divide it by 2. It's an even. 2 and 36 would get us to 6 and 6, 2 and 3, 2 and 3. And then we also have this W. Don't forget it. All right, 4 and 4 into something over here to keep going with 16, 2 and 2, 2 and 2. All right, let's start building. Our lowest number here is a negative 1. They both have it. So a top negative 1 and a bottom negative 1. Gone, gone. All right, next number is a 2 on the top. 1, 2, 3. 1, 2, 3. 1, 2, 3. Get them all. All right, on the bottom, there are 4 2s. So 1, 2, 3, 4. This column is done. Don't put anything in the top. Go to your next column. Our next number is a 3, and it goes here. It cannot go above the 2, so be careful. All right, that doesn't work. All right, and then a W again in our next open spot. All right, columns that are completely full are part of our GCF. So 1, 2, 3, 4 things we have to multiply by. All right, -1 times 2 would give us a -2. -2 times 2 would give us a -4. -4 times 2 would give us a -8. So our greatest common factor value we're pulling out here is a -8. All right, 2 ways to get what's left over. Take your -72W divided by 8, and take the 16 and divide it by 8. Did I miss one? 2, 4. Ooh, my fault. I made a boo-boo. This guy here is another 3. I left him out of my chart. All right. Boop. Don't forget that guy. All right. So this top represents what's left over of our -72W. So I can eliminate. 3 times 3 times W would give us a 9W. Right? That's option 1. Or I could just divide -72W divided by -8 would give us that positive 9W also. All right, gone. All we have left here is a 2, so in a positive 2, so plus 2. Sorry for my mistake. I now got that last 3 in my chart, which was needed. All right, our factored completely version, -8 times 9W plus 2. All right, number 3, we want to factor completely -15G plus 20. Again, some of these, as we get better at them, maybe we see that biggest number we can pull out front. But for today, we're doing all the work so we know how to do it when we can't just see it. So -1 and 15, +1 and 20 get you started. All right, from there, 3 and 5 here, and a G. Over here, 5 and 4, and 2 and 2. All right, make sure I get everything this time. All right, our lowest number is a -1. It only goes on top. All right, it's right here. Our next number is a +1. It only goes on the bottom, and those do not get lined up. They are not the same. They're different. All right, our next number is a 2, and there should be 2 of them on the bottom for the 20. All right, our next number is a 3, but it should only be on the top for our 15. And then they both have a 5, and the top one has a G. All right, so our GCF value here is 5. So again, for this one, I may have been able to look at 15 and 20 saying the biggest thing is a 5. Pull that on out. All right, now that's gone. We have a -1, 3, and G that's left over on top. So -1 times 3 times G would give us a -3G. Or I could have taken this -15G and divided by 5 to get the -3G. Be careful, you need your negative sign there. All right, on the bottom, we have 1 times 2 times 2 left over. So 1 times 2 times 2 would just give us a plus 4. So good factored completely version, 5 times -3G plus 4. All right, number 4, -10M minus 85. All right, these are both negatives. We start with -1 and 10. We start with -1 and 85. And then we can break it down from there. All right, over here, 2 and 5, pretty simple. And an M. All right, 85 ends in 5. So we know that 5 goes into it. In this case, it would be 5 times 17, which is prime. All right, we're now ready to make our chart. They both have a -1. Gone. They both have a, this one has a 2, but they both have a 5. Gone. The bottom one 17, and the top one an M. All right, so for this one, they both share a -1 and a 5. So -1 times 5 would give us our greatest common factor of -5. Or the biggest thing that they both have in common is they both have a negative in common, and they both have a factor of 5. All right, so -5. All right, leftovers. 2 times M. 2 times M. And positive 17. So plus 17. Factored completely. All right, that's parentheses. All right, -5 times a 2M plus 17. All right, let's try one more. Number 5, 32M plus 40. All All right, these are both positive, so 1 and 32. 1 and 40. All right, 32 and 40. Don't forget your M. All right, 32, there's a bunch of different ways you could break it down. I could divide by 2, I could divide by 4. Right? I don't know, 4 and 8 would be a way to start. Right, there are others. Take your own path. In the end, we'll all land at the same result of prime stuff. A bunch of 2's there. All right, over here, 40, again, a bunch of different ways we could start. We could divide by 2, we could divide by 4, we could divide by 10, right? I don't know, I'll go 4 and 10. But again, there's different options there. As long as we keep going until we're prime, we'll all match up in the end. All right, so let's start building. They both have a 1. Eliminate, eliminate. 32. 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5 2's. Bing, 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 bing. All right. Over here, 1, 2, 3 2's. 1, 2, 3. These have to stay blank. Don't put stuff in them. All right. From there, the bottom has a 5. The top has an M. All right. Now we're ready to go. All right. They share all this. So 1 times 2 times 2 times 2. All right, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. So our greatest common factor here is an 8. All right, so option 1, I take these and I divide them by 8 to see what's left over, right? That works. Or I go back to my chart. 2 times M is the first leftover thing, which would give us a 4M, which I think we see is the same thing I would get here if I just divide that by 8. And then down here, 40 divided by 8 would give us this leftover that we had here of 5. All right, factored completely version. 8 times 4M plus 5. All right, I hope that helps you complete your work for today. See you guys later.